Hey guys, we're back with the Jetta here, and looks like this video has been having a lot of anticipation about diagnosis on the car now. So we finally got to it. I'm so excited I can't wait for the video, like some of you guys here.
Woohoo!
Okay, listen, there's a lot of steps that we're going to cover on this car, and there were so many steps that I actually decided to write these things down. So we're going to cover all of this, and we're going to cover this, and we're going to cover this. So there's a lot, but I'm going to put it all in this one video. Might be a little long, but it's all going to be right there. Alright, so since we got that out of the way, I want to say some other things here too, but right up front in the video before we get started. If I put it at the end, you probably won't watch it. So first I want to say, with all of you guys out there, just remember this. You are just as smart as everybody else. I am no smarter than you. You're just as smart as me. Okay? The only difference may be that I might have a little more knowledge than you do. That's why I'm taking all this time to put these videos together so that you can understand the system. You know how it works. That's why we went over the vacuum diagrams. That's why we went over the electrical wiring diagrams. That way, now you'll know as much as I do. From that, you'll be able to develop your own diagnostic methods. And what you want to do throughout this diagnostic method, you want to make sure that you ask yourself questions. How can I check this? How can I verify that this valve is opening and closing? You got to make sure that you want to ask yourself questions to verify your prognosis, and then from there you'll go ahead and develop your own methods. Okay, so let me talk about where we're at, what I've done. Okay. First, let me get some of these components up for you. Alright, if you remember, we had a brake booster line here that was busted. Now we can get a real good look at that. Alright, let me see if we can find it. Okay, see there's a split. Now you can see that's going to be a really bad vacuum leak here. That's possibly why we had this P1136. Also, as I mentioned in a previous video, very possible that's why we had the secondary air injection system flow not detected. Okay, so that's been replaced. Okay, for that, look at a price of about $48. You'll get this whole thing. Okay, let's chunky them out. Alright, next thing on the list, we got a PCV breather hose. Now when you buy this, you'll get this whole assembly. You'll even get this hose. Now let's take a good look and see what this here hole looks like. What do you think of that? Amazing, isn't it? Okay. Look at the price of that right there. $56. Okay, in the process of replacing the PCV hose fitting there, well, guess look what we found here. This here port, which is right, all of this assembly is up underneath that PCV hose, okay? That PCV hose that I just showed you earlier. So you can see that the port's broke. There it is, stuck up underneath. So I had to get this joker. Well, you can't buy just this here fitting. Guess what you get? You get all of this right here. That's pretty nice of Germany to include all these hoses and all, and even this here fitting over here. Well, guess how much that's going to cost you? Well, that's about $73. I could not find this thing online anywhere, so I went to the local Volkswagen dealership, and he felt sorry for me, and I cried the blues and talked about how poverty-stricken I was, so he did give it to me for $62. Okay, so all of these components now have been replaced. Okay, one other thing. Let's go over here and look at the vacuum hoses. Now, here's the vacuum hoses. This is all the rubber that I found on here, so it's been replaced. And actually replaced the T's too. You know, being plastic, let's go ahead and replace it. We're there, okay? Now this here is thick walls, high temp, 3.5 millimeter ID. I put it in blue just so you could see it, okay? You can get these things in different colors. You can get them in black. You can get them in green, blue, just about any color you want, okay? Alright, so now that we got that all covered, let me go over one more last thing and then we'll get started on the diagnostics. You remember the coolant fan that we had? Okay. Let's take a look at that joker. Well, I did a little looking at that. Here's the one that was loose. Okay. Now, take a look here at the rear. I'm going to move it for you so you can see. You remember how before it was moving? Well, look at there. We got a bad bushing on the rear of this here motor. Okay. That's about 60 bucks for a fan motor. Now, you're already there. You see that this here thing is already shot. What do you think is going to happen to the other one? It's probably right on the verge of going out too. So, replace the other one while you're there. 60 bucks for each one of these here fan motors. So I went ahead and took care of replacing both of them. Why? Because I figured this one here is on the way to go anyway. It's like if you're changing a timing belt. Go on and change everything else in there. Change the water pump. Change the idlers. I just look at it as good assurance. And for $60, do you really want to go back into this thing later to replace the other one? So go ahead and replace both of them. That's what I've done. Alright, here's one other thing. Now I went ahead for you guys and I went ahead and measured up some resistance on these valves and for the relay coil. And also for the PVC heater. So you're not going to find this in the manual. So this is what you're going to find for yourself. This here is the injection air solenoid. Now the resistance on what I measured is 57.5 ohms. Now I'm going to put all of these resistance measurements in the video, so they'll be embedded in there, so you could, for you guys. Now for the intake manifold changeover valve, that is going to be 57.2. That's what I measured. So these two are pretty much alike. Okay. Now let's go up here on this here relay coil. Now the relay coil had a resistance of 65.2 ohms. Okay. Now the one for the PVC breather hose heater, which is right over here. Believe it or not, there is a heater in here for the PCV system. In the wintertime, when you're having blow-by gases coming back up into the intake manifold, what happens is that in the wintertime, when it's cold, that you may have a little bit of water vapor in there. And Germany felt like that with this here water vapor, you could get ice crystals in there. So this heater is on all the time. It is not controlled by the computer. It is a positive volts. When you start the engine up, it comes through the fuel pump relay contact. The other side goes to ground. This thing is on all the time. So the resistance of that, 24.5 ohms. And the reason I mention it now is in our diagnosis of this system. I'll explain later, why. I'm just going to keep it disconnected. Okay, with all your diagnosis, and not just this system, but in any system, try to do as much as you can using voltage. Try not to use resistance check in doing your diagnosis. I try to look at doing most of the checks with voltage. You can evaluate your system, you'll see what your problem is, and then use your resistance check to only confirm what you already know. So the first thing we're going to do, we need voltage. So we're going to get the battery back in here so we can get some voltage on the car. Okay, you can see the battery is connected up now. Remember the purple that I highlighted is a plus. This over here is a minus, and we're going to be checking the secondary air injection air solenoid valve. Now let's follow it up. Comes up, comes up, comes up. Goes through this here fuse 43, comes down, and it's also going through fuse 28. That's going to feed the fuel pump, and it's getting a supply from the fuel pump relay contact, which is open, and then comes back up, goes to the fuse 2 over here, which is hot at all times. As I mentioned earlier, I don't want to mess with this. So let's come back over here. Now what I'm thinking about doing is I'm going to energize this line right here. So we're going to T-pin it right here. Okay. Now when I make this hot, let's follow it out and see what else is going to happen here. Well, it's going to go through this fuse, coming down, and up through this fuse, and here comes the fuel pump relay. The fuel pump is going to start up. I don't want that to happen. So here's what we're going to do. I'm going to pull this fuse 43. Okay, so when the voltage comes up that I'm going to feed on this line, it's not going to go down here. It's not going to come to here. It's not going to energize the fuel pump. It's not going to branch out and feed other things. So that's good. Now, when we get back over here, while we're down there, we're going to check this. We're going to check the intake manifold changeover valve. See the purple? See, it's on the same circuit. Well, follow across, follow across, follow across. Goes through this fuse 34. So let's also remove fuse 34, and then that way, when this becomes hot here, it's not going to go through here, of course. And then when I come back over here, make this hot, it's not going to come back, and it's not going to feed back and making hot on everything else. Now, if you look right here, here's this here positive crankcase ventilation heating element. Okay. Now you can see that this joker is hot all the time when the car is running. It goes straight to ground. It's not PCM controlled, and you can see the positive voltage goes all the way back, goes through this fuse, comes along through the fuel pump relay contact, hot at all times. So whenever the fuel pump is running, basically this heater is on all the time. Okay, so in our test, I'm going to remove this connector just so we don't have to worry about it drawing current. Okay, the other thing is that when I remove this here fuse right here, we don't have to worry about this fuel pump coming on, deadheading pressure, and also drawing current off the battery while we're doing our test. So here we go. Fuse 43 is removed, fuse 34 is removed, and then we're going to do our test. Guys, so as I mentioned in the wiring diagrams, we're going to pull fuse 43 and fuse 34. Okay, now when you pull these fuses out, before you pull them out, verify that the amperage on the fuse matches up to the wiring diagram. You know, with a previous owner, he could stick in a 15 or 20, you know, who knows what kind of amperage he might stick in there. Now both of these fuses are 10 amps, so let's get the 43, which says he's going to be right there. So we're going to pull him out. Now, also we're going to pull out fuse 34. 1, 2, 3, 4, up in the middle row, 1, 2, 3, 4. He is a 10 amp, so he verifies that he's also okay, just like the other one. Okay. Okay. Now look at this here. Look at this wire. Remember our purple here is going to be positive volts. Okay. Now this is a blue with a yellow tracer. Now the connector pin is number 1. Now take a look over here. And I want you to look at this here coloring of this wire. Look at the very back. You see it's a blue with a yellow? Okay, this is where I have a T-pin stuck back probed into this connector. Now I have a fuse jumper right here. Now also for safety's sake, I got a piece of tape over here because we're also going to be using this pin over here for our ground. And our ground, if we look, is a brown with a yellow tracer. And if you look back up here on that wire, you can see that it's a brown with a yellow tracer. Now before you start stabbing these things and putting pins in, verify which polarity you're on, whether it's the plus or the minus. Okay, so now after we have that, we're going to take this jumper. This is a positive. Now I made this one up. Okay, I have a fuse in here. It's a 10 amp fuse. Now making one final look over, make sure there's nothing going to be touching on that positive. Okay, everything looks good. Notice I also have my ground pin here. I got it bent out away from the positive terminal. Okay, so I'm going to connect up here to the positive. Now notice that when we had that fuse 43 pulled out, we don't hear the fuel pump running. Okay. Alright, now notice I've got my black jumper lead here. Alright, it's just a jumper lead, doesn't have a fuse in it, and I'm going to go over here, right over here to the battery negative. Okay, now what we should be listening for is a click, an audible click. Hear it? You notice it's not very loud. Now you can put your fingers over it too, and you should feel it. And I do feel it moving in and out. Alright, so we know electrically it looks like that's working okay. Alright guys, now we got the valve out. Now we know this valve works electrically. But what we don't know is what's the internal passageway. How is that? Maybe this thing is not seating completely. Okay. Now, if you have a valve, you know, you're going to have air pressure going through it, or you're going to have some kind of vacuum. Now, what I like to do is I like to simulate the conditions of what's going to be on this valve. In this case, it's going to be a vacuum. Now, if you was to start, say, blowing through this here, it's possible that your air pressure, that when you're blowing it, then it's going to lift the valve up off the seat. Now, trust me, look at this thing. You know this thing doesn't have a very strong spring in here. So what'll happen is you could actually lift the valve up off the seat, and then it's going to blow through, and you're not going to really get a good indication if the valve is really seating. So what we want to do is we want to simulate this thing under a vacuum condition. So here's what we're doing. All right, this right here is where the vacuum source is at, and hook it up just like if you're going to, the way it is on the car. So I got my vacuum gauge here, so you know that's going to be pulling the vacuum. Now what we want to do is I want to see an actual load on this thing. So what I've done is I've unhooked it. Now this valve is the secondary air injection solenoid valve. Now this is the outlet port, and this is actually going to go over to the combi valve. Well, I can't really tell if the combi valve is working at this point. We're going to check that later. So what I'm going to do is I took and unhooked the line going to the combi valve, and I've hooked up, okay, this valve up here, the rotary servo valve up here is going to turn this barrel inside this upper plenum. So I should be able to see this here work. Okay, so now here's what I want you to look at first. The valve is de-energized. Now watch my vacuum. Okay, I'm pumping it up. Okay, now that right off the bat is kind of concerning me a little bit, because it looks like there's a, you know, all these valves has got to have a way to vent off the pressure when the valve is de-energized. So here's a vent. It's up here on the top. So it looks like that we're actually pulling, you know, through the vent right now, which tells me, you know, that's not a good thing, because that could actually create a vacuum leak. That's the way I'm looking at this. Because right now, if this valve is normally closed as it should be, de-energized, I would think I would be pulling up, you know, a pressure here, which I'm not. Okay? Alright. So, let's go ahead and energize the valve. Okay? And I can feel it moving. So now I've got the valve energized, which means now that the port should be open. So now let's draw some vacuum on here. Okay. Now you can see the vacuum is coming up. Not very fast, but now see it's jumping up. But let's take a look at a valve up here. Let's watch it too to see what it's doing. Okay. Okay. It looks like it may have already closed. Okay. Let me take the pressure off. Okay. Now watch the valve again. I'm going to pump it up. Okay. So now we see right now that this here is okay. Otherwise, if they had a busted diaphragm in here, this thing would never pump up. Now take a look at my vacuum gauge. There's a confirmation that the rubber diaphragm in there is also good. You see that it's not dropping. Okay. And I can pump it on up some more. Of course, the valve is already fully open up there. So that looks pretty good. Now, watch the valve up here. Okay, I'm going to take off and de-energize the solenoid, and it should release. Okay, so in one area this valve looks pretty good. You know, as far as it's when you open it, it is actually, you know, taking care of opening this valve. Now, if I do this, you can see that this here is not going up, right? And the valve up here is not actually coming on, right? The only thing that's concerning me is that we're actually pulling air, outside air, through here, right? And so that's the little thing concerning me. So we got the other valve down here, so let's check that one and let's see how that one works. Alright, we're on the intake manifold changeover valve. Now, this here top wire is a yellow with a black tracer. That's where our 12 volts positive is going, so I'm going to stick them down in there. See if we can't get us a good connection in there. Okay. Now, before you hook up the battery positive, let's just go ahead and get our negative end down on that. By the way, that color that is a violet with a brown tracer. Okay, now let's hook up our battery positive. Okay, now we're going to go ahead and we'll hook up our negative here. Going to battery negative. Now, can you hear it? So we know electrically the valve is working, but we don't know anything about the internal valve itself. Now what we're doing now, this is a vacuum source, right? I unplugged the line, you can see it's right there. Now this here is going down to my vacuum gauge, okay? Now this valve is the intake manifold changeover valve. This is the outlet. Now this outlet is going back up there to the rotary valve that we looked at earlier. Okay, so we're going to use the same valve. Alright, now the valve is de-energized, which means that it should be normally closed. Okay, so let's go ahead and pump it up. Okay, what do you notice right off the bat? You notice how the gauge here just pumped right up? No problem. Okay, now let's take a look. Let's release the pressure. Okay. Alright, now remember, the valve is still normally closed and it's de-energized. Now what we're going to do now is we're going to come up here. Let's take a look at this here rotary valve. Okay, go ahead and actuate it. Keep pumping. Okay, you notice how the valve up here is not actuating, it's not moving. So we know right now that valve is closed just like it should be. So what do we know about the other valve? It is screwed. So I got to get a secondary air injection solenoid here. This one here looks to be okay right now in the de-energized state. So now let me go ahead and energize this valve and let's see what she'll do. Okay, go ahead and we'll release the pressure. Okay, back to 0. Alright, going to hook up the DC negative. Okay, go ahead, pump it up. There it goes. Go ahead. Okay. All right. Now while she pumps it up, let's go ahead and watch the valve. All right, go ahead and pump it up. Pump, pump, pump. Okay. Let's take a look at our gauge. Okay, go ahead and pump it up. Okay, that's looking pretty good. Pretty good. It's holding. Okay, get the glare off of there. That looks good. Now let me release the pressure. Okay, you heard the rotary valve snap back. All right, let's try it one more time. Go ahead. Looks good. Looks good. Rotary valve. Yep, it's down. I'm going to release the vacuum. Okay, so that looks good. All right. Okay, guys, I did it on the previous valve, but I didn't explain what was going on. This is an important step. With the valve energized, get your vacuum pumped up. Okay. Now you see our rotary valve is actuated like you saw before. Okay. Now what you want to do is you want to de-energize the valve. Now, here's what's going to happen. When we de-energize the valve, all the vacuum pressure that's in here feeding this here has to go somewhere. In other words, if we de-energize this here valve, and for this to come back to its normal position, that vacuum pressure has to go somewhere. So it's got to go out through the vent assembly of this valve. All solenoid valves got them. Two-way valves, three-way valves, it doesn't matter. Now, so when I de-energize it, what you want to look for, you want to see this here, you want it to snap. You want this air pressure or vacuum pressure that's inside this line, you want it to vent to the atmosphere quickly. So here's what we're going to do. We're going to look at this here and watch this here valve, and we're going to see how fast it will close. Now, if we de-energize it and it slowly goes down, then we know we got a problem with the vent assembly over here on this here solenoid. Now, at the same time that when this here, let's say this thing snaps, that's good. We're going to also look at this right here. We also want this pressure to be holding. Why? Because when this here solenoid snaps shut, okay, all of the vacuum pressure that's on the outlet of the solenoid valve going up to here is going to be vented to the atmosphere. However, on the other side, on the source side, which is where we're at, that valve is going to come down, snap, and it's going to hold that vacuum in there. So that's what we want to see. So let's go ahead and let's do it and watch. First thing you want to watch is watch this right here, and you also watch this gauge. We want this here snap shut. We want this to hold. So I'm going to de-energize it now. Now you see how quickly that this came back? Okay, so we know the vent assembly on this solenoid is good. Now take a look at this right here. Now, I'm going to energize the valve. Now when I energize the valve, what's going to happen is it should drop back to atmospheric pressure. Why? Because when we go back and energize this valve, what little bit of vacuum I have is just in this here to this here source port up to my gauge. So what's going to happen is this here vacuum pressure is going to rush, come down, and it's going to fill this line and fill this chamber, but it's going to be so much capacity here that this here vacuum is not going to be enough to fill this whole line up, if that makes any sense. Okay, so I'm going to energize the valve, and you see how it dropped down? But you notice that the valve up here did not move because we didn't have enough vacuum capacity to operate that load. Okay, this is a good place to end this video. So you guys stay tuned, and we're just going to progress on, and we're going to just check every single thing on this here secondary air injection system. So I think it'll be an interesting video. So I appreciate you guys watching, and we'll see you in the next one.